Okay, so this is the homework that was due on Friday night. I figured I would post a video of me going through all three of them in case you struggled with it. So first I'm going to do the one with number one, Arnold and Bertha Squirtington. They're visiting 3 national parks. This method of bearings is actually the same as the day one method. I would have put this last if I had realized it. So this wasn't actually practicing the new method. But either way, let's start. So I always like to start with listing the bearings in order as how they're listed in the problem. So it says the bearing from Grand Canyon to Mount Rushmore is 51. I like to make the list because then it kind of helps me figure out which one to do first and not having to look back to all the words. So now we have Yellowstone to Grand Canyon is 206, and Yellowstone to Mount Rushmore is 80. Okay, so they tell us to find all missing interior angles and distances created. Now remember, anytime you have a location that has 2 different bearings from it, like Yellowstone here, do that one first. It doesn't matter which one you do first, but I'm going to do my Yellowstone location first. So I'm going to plot Yellowstone anywhere. Here's my Yellowstone, and I'm just going to go through and do these. Now, to get the 206, since that's bigger than 180, you have 2 options here. You can either come from down here and do 206 minus 180 and go this direction, which would be 26 degrees in that direction. Because remember, 206 is from here all the way around. Or you can do 360 minus 206 and go that direction. It doesn't really matter which way you do it. I think I typically tend to do 360 minus the angle, but since this was pretty close to 180, let's just do 206. Where are we? 206 minus 180, which is 26. And so I'm going to go 26 degrees from here, this way. So over here. Remember, anytime you're doing bearings, as you make the bearing angle, you have to make sure that you label the angle so you have that value for later. Okay, the next I'm going to do, so Grand Canyon is going to be somewhere down here. I'm not going to pick a spot for the Grand Canyon quite yet because I'm going to make, well, I guess it doesn't really matter. I can pick it anywhere. Never mind. The reason why I can pick it is because there's not another bearing coming to Grand Canyon. So when I go back to do this one, I'm going to have to pick the spot anyway. So I may as well do it now. All right, so now I'm going to do Yellowstone to Mount Rushmore, which is 80 degrees. Now this one is the one that I'm not going to put a spot for yet because I'm going to do like the intersection of Grand Canyon to Mount Rushmore and Yellowstone to Mount Rushmore. And that's where Mount Rushmore will be. Okay, so now Grand Canyon to Mount Rushmore is 51 degrees. Now, remember, anytime you need, you're going to draw a bearing, you need a bearing line. So I want 51 degrees from Grand Canyon. So about here, and then connect that to get Mount Rushmore. And then this whole thing was 51 degrees. Okay, so that's what the basic picture looks like. Also, Grand Canyon to Mount Rushmore is 736.64 miles. Okay, so now I need to fill in as many angles that I possibly can because we want all interior angles of this figure and we want all of the sides. So let's take a look at the triangle that we want to focus on. It's this triangle here. We want all those interior angles, which this one we do have is 126, and now we need this angle and this angle. So if this whole thing is 51, notice this one's 26, so this one and this one are both 26 because they are alternate interior. So if this one's 26, then this one's going to be 25. So this angle is 25 degrees, and then you can do 25 and 126 from 180 to get that this one's 29. Okay, so I have all interior angles. I have 29, I have 25, I have 126, I have 25, I have 29. So now we're going to use those angles and this side to find the 2 sides. So this is not a right triangle, so it's law of sines. So I'm just going to show my setup in my solving that I did earlier. I figured you probably just needed the most help with drawing the picture. So if you take a look at, this is my work I did earlier. I had sine of 126. So first I found x. So I used 126 and this are opposite each other. And then 25 and x are opposite each other. Remember, that's what you need for law of sines, is an angle and a side opposite, an angle and a side opposite. So I did sine of 126 over 736.64 equals sine of 25 over x. Cross multiply, you get that x is 384.81 miles. Then to find y, I use the 126 and the 736 again, and then I use the 29 and the y. So there's my setup and my solving for that. The last thing it asked to do is find the bearing from Mount Rushmore to Grand Canyon. So that I'm going to show out on this one. So from Mount Rushmore to Grand Canyon, in order to find that bearing from Mount Rushmore to Grand Canyon, we need a bearing line. So you need a vertical line through Mount Rushmore. So take a look at the line that connects Mount Rushmore to Grand Canyon. It's this line here. So really what we're looking for here is the angle from here all the way around to here. That's what the final question is. What is the bearing from Mount Rushmore to Grand Canyon? So really what we're going to have to do is find as many angles as we can. One thing that pops out to me is this line is parallel to this one, obviously, with this transversal. These are consecutive interior. So if this is 80, this one's 100. So what you can do is notice that this bearing from Mount Rushmore to Grand Canyon is everything, almost like it's like this full circle, subtracting this part, this one. So this whole angle is 129. So if you do 360 minus 129, that will give you the bearing. It's 231 from Mount Rushmore to Grand Canyon. Another way you could have done it is you could have filled in all these angles, like if this one's 80, this one's 80. If this one's 100, this one's 100. This 80 here is vertical to this, making this one 51. So you could have done 80 plus 100 plus 51 plus, oops, not 29, just these three added together. 80, 100, and 51 would give you 231 also. So that's how you find a bearing. All right, that's number one. Number two, we have some cities. So we have three cities. We have Winston-Salem. The first bearing that they give us is Winston-Salem to Danville, and that's 42 degrees east of north. Then we have Danville to Goldsboro, which is 48 degrees east of south. And that's it. Then they give us how far the person's driving, Mark Ferrari. So I like to deal with that later. Let's just draw the picture. It doesn't matter really which one you do first here, although it's probably a little bit easier to do Winston-Salem first, because we go Winston-Salem to Danville and then from Danville to Goldsboro, so we may as well go in order. So I'm going to make Winston-Salem here. We need 42 degrees east of north. Remember what that means is north is up here, east is to the right. So I want 42 degrees this way. Okay, so then here's Danville, let's say. Since I need a bearing now from Danville to Goldsboro, I'm going to need a bearing line. So you pick a spot on that line to be Danville, draw a bearing line through it. And now we need 48 degrees east of south. So south is down here, east is this way. So we're going to have 48 degrees this way, but from this vertex. Okay, so 48 degrees is about here. Remember, we're just estimating. So as I always have said, if you don't have a protractor, that's fine. Okay, so this is 48 degrees. And then we connect. So here's Goldsboro. Okay, what else? Let's find some more angles. So notice these are parallel. So these are alternate interior, making this one 42, making this a right angle. We can't find any of the other angles, so we don't have enough information. So let's go move on to the side. So it says a car driven by Mark Ferrari traveling 60 miles per hour takes 1 hour to go from Winston Winston-Salem to Danville. So this is 60 miles per hour times 1 hour, which would just be 60 miles. So that's this one here, 60 miles. Then Danville to Goldsboro, it says 1.8. So 60 miles per hour times 1.8 hours is 108 miles. So this one's 108. So we want to know, find the distance from Winston-Salem to Goldsboro. So here's an example. Because it's a right triangle and we know two sides, we could have done Pythagorean theorem, or you could use trig if you wanted to. I'll show you the work done out for both of those methods. So here is Pythagorean theorem. So 60 squared plus 108 squared equals x squared. You end up getting 123.55. Another option would be to do a trig equation. So over here I found the angles by using inverse trig functions. So I found, it looks like I found this one first. This is opposite, this is adjacent. So I did inverse tangent 108 over 60, and I got that at 60.95. If you subtract from 90, you get this one's 29.05. From there, if you wanted to, you could have used, say, this one, and this one, x, to find this hypotenuse. So you could have done like sine of 60.95 equals 108 over 108, over x, and you would have solved and gotten 123.55. Either way works. All right, so that's that one. That last one was a little funky because they only gave you one bearing, so that means that you had to find all of the angles. So we have Kit Kat to Twix is 12 degrees east of north and 325 miles. We have Kit Kat to Hershey Kiss, which is 200 miles. We have Twix to Hershey Kiss is 450. So this one only gave us one bearing. So I'm going to draw my bearing line. So what that means is a lot of the triangle that we're going to be making is going to be just like an estimated. It's not going to be drawn to scale fully because we only know one angle. And it's from Kit Kat. So I'm going to mark Kit Kat on here. It's 12 degrees east of north. So that's 12 degrees to the right, which is here. Okay. So that's Kit Kat to Twix. So I'm just going to pick Twix here. They didn't give us the bearing from Twix to Hershey Kiss, so we're just going to have to estimate. Notice that this one is 325. Twix to Hershey Kiss is 450. That's the longest side, so I'm going to make this the longest side. Now, we don't know what this angle is going to be, so I'm just going to make a random one. And then this bottom one is the shortest side at 200. So I'm going to try to make that look like it's the shortest one. Do your best though, like it's fine if yours looked a little different from mine. And that's Hershey Kiss. Okay, so what we have to do here, notice again, we only know this 12-degree angle. We don't know any of the other angles because we weren't given any other bearings. So what we're going to do is we have to find all of these angles. I'm going to find this one first. Using the 450, and I'm going to do law of cosines. So I'll show you the work real quick for that. So here's the work for the law of cosines. It was 450 squared because that was across from what we were trying to find, equals the other two sides squared minus 2 times 325 times 200 times cosine of x. So I did all of the exponents. I did this part is negative 130,000. I moved the 145, 625 over. I divided by negative 130,000. Then I did the inverse. So it's 115.94. So I'm going to label that over here. The next thing that I did is I found this angle. You don't have to do law of cosines again. You can do law of sines. So here's my work for that. So I did sine of 115.94, the one we just found, over 450. Equals sine of y over 325, cross multiply, and you get that it's 40.5. So I'm going to label that in my picture, 40.5. And then you would just subtract these from 180 to get the last one, which is 23.56. Okay, so those are all of the angles. Next, it also asks, it says, what is the bearing from Hershey Kiss to Twix? We already found all the interior angles. So Hershey Kiss to Twix, we need a bearing line through Hershey Kiss. So you need the line through whichever one it says from. So from Hershey Kiss to Twix means we want from here to here. So basically, if I can find this angle here, subtract that from 360, that would give me my bearing from Hershey Kiss to Twix. So what I did was I noticed that this whole angle here and this entire angle, those are consecutive interior. So if you do 115.94 plus 12, that's going to be 127.94. And if you subtract that from 180, hold on one sec. If you subtract that from 180, you can get this angle. Subtract 40.5 from that, and you would get this one. It ends up being 11.56. So really what you can do is just take 12, 115.94, 40.5, add those together, subtract those three from 180, and that will give you this one. So what you can do is when you write your bearing, you can actually stop here, because you can say the bearing from Hershey Kiss to Twix is 11.56 degrees west of north, because it's to the left of north. Okay. You could also do 360 minus 11.56, and you would get 348.44 degrees. So you can either list your bearing as one angle, or you could use the second method, which is always using an acute angle. Doesn't matter. All right, so that's the homework. If you have a question, please email me at some point today. Tomorrow, our Zoom is going to be at 11:30. That's our new time for our normal Zooms every day. So join me then, or feel free to email me today. We can hop on a Zoom today if you want to as well. All right, have a nice day.